Now let's look at the one problem. Let's look at the problem 78. Y equal to the cosecant of the 3x plus pi. We need to determine the period and sketch at least one cycle of the graph of this function and state the range of this function. So this page 475, problem 78. So function y equal to cosecant of the 3x plus pi. So first, let's get the period. So period is equal to the 2 pi divided by the coefficient of x. So divided by 3. 2 pi over 3 is the period. And the range. So the range for the cosecant actually is similar to the range of the secant function, right? So the range of the cosecant is just equal to the union of these two intervals from the negative infinity to negative 1, union the interval from the 1 to positive infinity. So for this one, it has the same range. So the range is equal to the union of these two intervals. Okay. Now let's determine one cycle. Let's begin with the fundamental cycle of the original cosecant function. So we net 3x plus pi bigger than or equal to 0, less than or equal to 2 pi. Then we subtract each part by pi. Then we get negative pi less than or equal to 3x and less than or equal to pi. Right. Then we divide each part by 3. We get the negative pi over 3 less than or equal to x, and which is less than or equal to pi over 3. So now, as in the previous example, we begin with the function y equal to sine of 3x. And for this one, its fundamental cycle is from the 0 to 2 pi over 3, right? Because you net the 3x greater than or equal to 0, less than or equal to 2 pi. And then immediately you can get the fundamental cycle corresponding to this y equal to the sine of the 3x. Now, based on the graph of this sine of 3x, then we can find the graph of the sine of the 3x plus pi, which is equal to sine of the 3 times x minus the negative pi over 3. So that means to get the graph of the sine of the 3x plus pi, we may first draw the graph of the sine of 3x and then translate the graph of this function to the left, right, because of this negative sign, to the left by pi over 3 units, then we get the graph of the sine of the 3x plus pi. So let's draw the graph. And we know we have the graph of this sine of 3x like this. Okay. And here this is the 2 pi over 3. So this is pi over 3, right? Now you translate this graph to the left by pi over 3 units. Then you get the graph of the sine of the 3x plus pi. So pi over 3, so this point is shifted to here, right? Then we get the graph. And this point is shifted to here. So we get a graph like this. Okay. So this red one is graph of y equal to sine of the 3x plus pi. Now, at the point where the sine of 3x plus pi equals 0, we have the vertical asymptote for this y equal to the cosecant of the 3x plus pi. Let's draw the vertical asymptote. So you have the vertical asymptote here, and here, and here, right? And then based on the graph of this sine of the 3x plus pi, we can draw the graph of the cosecant of the 3x plus pi. So done. So in this way, we find the graph of the y equal to cosecant of the 3x and plus